Vanakkam, Namaste, Namaskar. Welcome back to one more session with Jal Prayag. I'm planning to continue on the chart work. If you remember, the last video I had done was a chart triangle, and we had dealt with using the current, the ocean current, and how I form a chart triangle. And we even saw what is an allowing method of chart work question. So I'm going to continue on the same allowing method. This time I'm going to add in one more feature of environment, which all of you know. It is the wind. So when you don't have the current or the wind, then it is a plain simple sailing for you. All you have is your CTS and your engine speed. But moment environmental forces starts coming into picture. The first one was current. We already saw earlier in the last video that we can form a triangle. And this time I'm going to look into the second part of environment, which is your wind, or we all also call as a leeway. So let us look into this continuation of the concept of chart work triangle. So initially what I'm going to do is I'm going to tell you how the wind affects your motion of the vessel, and then I will link it or merge it with the chart work triangle. So let's quickly go into the topics, but before that, a quick recap of definitions. I'm not going to spend too much time, but just let us have a look on what all we saw. We saw what is a dead reckoning. So DR is applying your course steered engine speed to your initial position. Then we even saw what is estimated position. So you arrive at estimated position whenever you have estimated environment. So estimated environment earlier was the current. And then the last important definition as far as your chart work triangle is concerned is a fix. So fix is your actual or the true position, your observed position. I'll be soon making one video, maybe the next one, which will talk about various methods of getting a fix on board and how you use that tools. I'll make it soon after this video. And then last class, we saw what is current. Whenever we talk about current, which is also called as set, and the speed is also called as a rate, it is always given as going towards a direction. So this is important for you. The reason for me to recap this was when you look at the leeway or the wind, you will see it is slightly opposite. That is the protocol we use in chart work. So the current direction is always going towards. I'll just quickly give you an example of a southeasterly set. So please have a look at the southeasterly set. That means the current is going towards southeast. So this is the direction. So if there was a vessel, please remember this is how that vessel is going to drift because of the current. It will get pushed. So you can see the vessel is pushed in southeasterly direction because of a southeasterly current also. Now, the topic for this module today is wind. So let us quickly look at wind and how it is depicted and how we are supposed to use it in our practical life or the chart work problems also. It is exactly opposite of what we just saw as the current. Current is always going towards, the direction is always going towards, but the wind is the direction always where it is coming from. So if I give you an example like this, let us say I have a wind coming from here and my vessel is here. For me, it is the wind coming from. So you should agree that this direction is approximately northwesterly wind. This is how a wind is depicted. Now, one more thing. How do you quantify? If you remember in your current, we always had a set and a rate. Set was the direction and the rate was the speed. But here, we are going to quantify leeway as a small angle. So how that angle works, let me just quickly show you after a couple of steps. I'm going to give you an example. Northwesterly wind, 3 degrees leeway. This is how wind is quantified in your exams, in your questions. But you should realize that if I have a northwesterly wind, my vessel is going to get pushed towards the southeasterly direction. So this is the change between how a current is depicted and a wind is depicted. Okay. Now leeway, as I told you, is in the form of an angle. You always give it an angle only. And what is this angle? This angle is uh, the angle with which it affects your course steered track, or CTS, course to steer, whatever it is. So what is the angle with which it affects the course steered track? That is what is your leeway. And normally for a wind, we don't apply any change in speed. I'll come back with a small liner for telling why we don't consider the speed. So I'm giving an example. Let me say my vessel was moving due north, and I had a westerly wind with a leeway of 3 degrees. Now, this is what is going to happen to the vessel. I'm going to draw one more track, which is exactly 3 degrees on the downwind side. That means on the leeway side, on the lee side, I'm sorry, lee side. Okay. And this new track is what I'm getting because of the wind coming from westerly with a 3-degree leeway. So what does it mean? It means that the vessel is not going to be on my course steered track, which is due north. It will be on this track, which is a new one, 3 degrees, which is on the lee side of your vessel. Now, this particular leeway angle can also be depicted as difference of angle between the 4.5 line of the ship. 4.5 line of the ship is very evident. It is due north, which is 0, 0, 0. And when you start looking at the wake of your propeller, the water, you'll see you'll get a wake like this. So the difference of angle between your 4.5 line and the wake of the water can also be called as leeway angle. So if you go and watch your stern, this is a good way of figuring out what is the leeway, how the wind is affecting your vessel. Okay. So there is a few cases of exception when the wind is coming from right ahead or from right astern. Please remember, it is not going to affect my track. The CTS track which we are talking about is not going to affect. It's going to affect only the speed. In the previous example, let me just quickly go back. If you see here, the wind was coming from either side of your vessel, so port or starboard. So whenever it is coming from either port or starboard, we will depict as if it is affecting the course steered track. But if it is coming from right ahead and right astern, it is going to affect only my speed, not the track. So just an example, let us say wind is coming from here or here. It is going to affect the vessel's speed slightly, but not the track. And this quantification, please remember, someone has to give me what is the quantity of the change of the speed. Otherwise, we are not going to use it in our exams. So somebody has to quantify. So normally you will see in the MMD exams, wind right ahead, right astern may not come. Why? Because otherwise it has to be quantified. What will be the change of the speed? Now, a quick comparison between the wind and the current. We have been looking at northwesterly wind, which is on the left side of the screen. And we have already seen what is southeasterly current. And this is exactly the same previous picture. You should realize one thing, that both northwesterly wind or southeasterly current is going to push the vessel in the southeasterly direction. So this is something you need to remember, how to depict the wind and the current and what is going to be the effect of both of them on your vessel. Okay, something important to understand. Let us say that I make a ship float and I throw a piece of wood on the water also. you will see the current basically is the full bodily movement of the water. So the whole water is moving, which means effectively the ship also will be drifting at the same rate and the same direction as the piece of the wood also. So this is what is how the current works on your vessel. But please look at the wind. The wind depends on the windage area. How it is going to affect my vessel is going to depend on the windage area and the heading also. We just saw in the previous slides, when the winds are coming from either direction is affecting our track, but when it comes from right head, right astern, it affects the speed. So that means the heading is also important to judge your what is the effect of your wind. Now this windage area, please remember, it changes with the type of the ships. Let me say a container ship or a tanker is completely different. Let us say a car carrier or a general cargo ship is completely different. It will depend on the size and whether you are loaded or ballast. Why? Because the windage area directly depends on the above water volume. I mentioned here in the bracket above water surface. I'm sorry, not the volume, surface. The surface which it presents above the water is very important for you to take a note of how the wind is going to affect you. Okay. Uh, how this windage area is looked into and how the vessel is affected is more of ship handling part of it. So we are not dealing on that particular topic. So right now, let us only look at what is required for your chart work questions. Now, let us quickly again see how this effect of leeway and leeway track comes into picture. So I'm going to show you one by step by taking some examples and then values. Again, as a quick recap, as far as the wind is coming from the sides, which is your port or starboard, it affects only the direction of your track, which you're following. It does not affect your speed. And the reason is your lateral resistance. Again, this lateral resistance is a topic to be covered in ship handling. So we are not going to deal with it. It's only an indication for you to understand why it is not affecting your speed. Let us quickly look at a small example. Let us say at 8 o'clock, this was my fix, okay? And I was steering some course, 045 or whatever it is, or 040. And the wind was coming from northwesterly direction and the leeway was 3 degrees. So I'm going to push the vessel, the wind is going to push this vessel on the lee side and is going to create a new track called leeway track. So how do you differentiate between your CTS and the leeway track? Is a simple angle of the leeway, which is your 3 degrees. So it's very, very evident that my leeway track is going to be 043 degrees. I've already mentioned, as far as the winds are coming from sides, do not change the speed. So you can see the CTS was 04012 knots. Leeway track is 043 and 12 knots. Okay, this is how it works. Now, during, let us say 1 hour, let me take a duration of 1 hour, 8 to 9 o'clock. You will see the vessel's position will be on the leeway track, not on the course steer track. So you will be somewhere here. So after 1 hour, you will be at the end of the leeway track arrow. That is where you will reach. So let us see what is the next feature what we're going to get. It's very important for you to understand that even though the vessel's position was on the leeway track during this last 1 hour, leeway track is 043, but your vessel was steering 040 and the autopilot was maintaining your heading. So that means your vessel's heading was like this. So this is important for you to understand. So I am on the leeway track, but my fore and aft line of the ship is still 040. So what happens to you after 1 hour? After 1 hour, you will reach a position called DR. And I've just marked it DR wind. My idea is just to differentiate between a DR, which I told you earlier in the previous module. If you remember, I can get a DR on my CTS track also. If there is no wind, there will be a DR on the CTS track after 1 hour. And that DR I had mentioned as only dr. To differentiate between that and this dr obtained because of the leeway, I'm marking it as wind. So it is only an indicator. You may not find this bracket wind in any of the books. So it is also called as dr. You can still call it dr. But my aim is to differentiate between both the drs, just to tell you this is something different. It is not the same, it is something different. Okay. So if only wind is given, you can see if only wind is given in your question, please apply the estimated wind, which is your northwesterly wind, 3 degrees leeway. Apply it on the course steered, and you will get a resultant called leeway track. Okay. As I mentioned, DRW or DR wind is only an identifier to differentiate between the earlier DR we had seen in the previous module. You should realize if only wind is given to you in the question, this leeway track can also be called as the course made good. But I suggest please don't use that because it is a confusing factor. The next example where I'm going to talk about the current and leeway, so you will start talking about two CMGs. So that is why it's better to leave it as leeway track. Just leave it as leeway track. This example, what I've shown you is just now we have seen it. I'm going to give you one more example. Let us say vessel was steering 060. Wind is coming from southeasterly direction 2 degrees. So your leeway track is going to be 2 degrees off. So 058 and 12 knots. End of the day, you will be facing like this. Your positions will be on your leeway track and you will reach your DRW. So this is just one more example of how the wind is going to affect. Let us incorporate this leeway into our allowing method of chart work triangle, because just now what we have seen is only the wind part of it, and wind normally affects only the track, so it is not affecting the speed. So let us try to put it on the allowing method where I'm having a current as well as a leeway. So I'm going to give you a small example. Let us quickly see. Let us assume that course steered is given to me. Leeway is also given to me. Engine speed is given. Set given. Rate is given. CMG and SMG is not given. One peculiarity you should realize that I've not given a new number for leeway. I've just mentioned in between 1 and 2. I'm still holding my chart work triangle with the same 6 components which I've been talking about earlier also. So I'm still holding on 6 components. So your leeway is incorporated into the course steered. Why? Because the engine speed does not change. So that is why, even though leeway is a 7th data, you can see leeway is still the 7th data, and I still need 4 data to solve. So I'm not going to include this leeway into that minimum of 4 data to solve. I'm not going to include. I don't need that. Okay, this is an additional data. So in this previous example, you can see I have components 1, 2, 3, and 4 given to me. Leeway is an additional data. Let us see how to do this allowing method. Okay. So I've given you northwesterly wind, 3 degrees leeway as an example. We already saw a couple of times leeway affects only the direction, not the engine speed. So how should I approach whenever a question is given with wind as well as current, and I'm trying an allowing method? Please apply the wind first. Why? Because the CTS is given to you already in the question. Allowing method means your CTS and engine speed should be given. So it was given in this example. So please apply the wind first, and then only you should apply the current. Okay. So let us start with the initial fix. Draw a small length of CTS, whatever CTS, it could be 040 or whatever. Draw a small length just to show this is your CTS. Then apply your leeway angle and draw that leeway track to this course steered, and the speed is still the same. Please apply that to initial fix. So I'm drawing a leeway track with whatever leeway angle. You will arrive at DRW, which is at 9 o'clock. Let us say is 1 hour problem. Okay. If there was only wind in this question, please remember this is how your vessel will be moving on the leeway track. But in this question, we have current also. Now I'm going to apply the set and rate to the DRW for the same 1 hour, and I'm going to arrive at estimated position. Now, if I join my initial fix and the estimated position, I get CMG and SMG. If you realize I marked EP as W plus C, the meaning is wind plus current. Why? Because the finally estimated position what you arrived is as a result of wind as well as current affecting you. That is the reason I have written W plus C. Okay. Now, once the current is there, please remember the vessel's course steer is still the same, but now your position will be on this track. This is where your vessel will be. Okay. So if both wind and current is given to you in any question, please remember apply the current or estimated current, whatever is given into the question, please apply it to DRW. So estimated current can be called as DRW to EP. This is also a way of calculating the estimated current. Okay. I'm going to show you on a chart to make it more realistic. Let me again give you the same example. Initial fix. Please draw the small line of CTS just to indicate that the vessel's fore and aft line is different. Now I apply the leeway. I come to DRW at 9 o'clock. Please apply the current only here, and you will arrive at the EP. Join these two, you have the CMG. So during this whole 1 hour, this was the fore and aft line of the ship, and the position was all along the green color vector, which is your CMG track. So this is how you solve an allowing method, including a wind, besides the current, which we saw already. I'm going to just quickly just redo the same thing what I did a couple of slides back, but with some values. So I'm giving you course steer 045, leeway as northwesterly 3 degrees. Okay. Engine speed 12 knots, set 150, rate 2 knots. So how do I proceed? The same example is exactly the same, only thing is with values. Please start with the initial fix. Draw a small CTS. Do not draw the full line. Do not draw the DR on the CTS track. Please draw the leeway track as 048 because I've given you values. Finish with 12 nautical miles. You will come to DRW. Apply 150 and 2 knots here. So you'll arrive at the estimated position. Please join these two to CMG and you will see the vessel's position will be along this track, but vessel's heading will be as per your CTS only, 045, it cannot change. And please remember, the vessel's position is always found on the CMG track. It's never found in any other track as far as your wind and current are concerned. So this was how you use your wind also in a chart work triangle problem. I hope it was simple and easy to understand. When I start doing other modules, you will see that I'll be incorporating the current as well as wind. So today what we have seen is how do I use allowing method. Allowing method means my CTS and engine speed should be given. So that is what is allowing method. I'll be using the same environment later on when I'm making video of counteracting also. Counteracting method also is very important. One of the basics of chart work triangle. We'll look into that also. Before that, I might make a couple of videos maybe on simultaneous fix or fixing tools, whatever different fixing tools also. And a couple of more, and then I'll be going to this counteracting method also. So I'll catch you soon. Till then, it's Namaste, Vanakkam, and Namaskar from me. Stay tuned to Jal Prayag. I'll see you in the next video as soon as possible.